talking about. And I've heard a version of this, I think, and it's pretty great. So I'm excited for you all to see it. And I hope everybody has questions. The reading comes from Garrett too. He doesn't want to admit it, but there's a relationship between the reading and this lecture.
Yeah, a little bit.
A little bit. See?
I might touch on that in this little part about what's on people's desks, or what has been on people's desks. So, yeah.
For those of us who didn't have you, would you give a very brief, like, maybe
yeah,
introduction to yourself?
Yeah, you're gonna get part of that. Yeah. So I'm excited to do this. Like Ben said, there was a version we did in tandem with last year's studio, which was a little bit of a different studio, but I've kept those parts in. And I think the way the precedent was formulated and that relationship, I'm supposed to talk into this, was done a little bit differently. But I left it in because I think it still applies. And it actually also built on having taught this three years in a row, the prior studio. So I think 3 years ago it was called formulated around this idea of a column plus, like a single element, and how to develop that single element. And last year was built on a sort of what I would call in this a series of generics, and so how to adapt a series of generics. And I know it's gone into some new territory, but I hope this still helps you all. So I think lecture is a generous term for this. It's a bit of a show and tell, and with some thoughts on structure. I gravitate towards architects who gravitate towards specific engineers, and so I think there are folks out there that operate like that. Certain offices, their work may be less dependent on an engineer or less dependent on certain ideas of structure, but I truly like and follow a lot of architects who might even say that their practices may be radically different or maybe not even possible without a close engineer relationship to an engineer. And so hopefully you'll see that. To some of the questions in the audience, I think the way I've thought about formulating a sort of career and an office and a path to an office is kind of laid out in these sort of 6 projects. After graduating graduate school, I started a small firm. The partner, Julian Rose, who is an academic and an architect. And so the first project we built, you will see, that's in here, that was under the moniker Formless Finder. We built with a lot of sloppy materials, and I think we had, we built a lot of small projects, and we had ambitions to build much larger things. And I knew there was a huge gap between what we were able to do and what we had sort of hoped to do at some point. And so the way I took that on was to work with a number of architects and work on some very large projects as a way to sort of cut my teeth on bigger buildings and to really learn how to build bigger buildings. And so I worked for Stephen Hall for a year, and then I spent a significant amount of time at an office called James Carpenter Design. And I'll be showing a number of those projects. I was senior design associate there, and I'll be showing 4 of the projects that I ran for that office. That is an office that works exclusively with Schleich Bergerman and partners as a sort of structural partnership. We had worked with other engineers while we were there, but about 95% of our projects were developed with the German firm Schleich Bergerman. Really interesting firm who I would say have even invented structural types, like the cable net wall could be attributed to folks at that firm, right? Things that did not exist in architecture that became possible through structure. And then the last project is kind of new project in my office, and it's a new office and a new trajectory, and it's sort of the first attempt at putting all of those things back together under a sort of new name. So trying to get at the scale and complexity that I was able to work at, under different offices, but probably for the first time by myself. And so I'll end with that project. Let's see. So I think you all are looking at this, right?
Yeah. It's the, yeah.
Okay.
We're in it.
You're in it. Okay. Okay. So, I mean, it'd be interesting to talk this out at the end, but I would put this book in the camp of engineering and structure equals a certain, or let's say structure equals a certain type of engineering elegance. And I think when 99 times out of 100, when you hear a structural engineer refer to elegance, it is it is both in the lightness of a structure and redundancy of a structure and the minimal materials required for that structure, right? If your column can be 5 inches, why would it be 5 1/4 inches, right? And I think there's that sort of thinking and methodology, albeit attached to different types of structure and different formal ambitions. But I do think of the Engel book as a book after a certain type of elegance in the sense of attaching it to reducing everything to its smallest amount of material and, well, I won't say form, but smallest amount of material. So I won't show any of this, but we didn't look at this book that much last year, so this is from last year. And I find it interesting that this is the book that I see on most people's desk now related to thinking about structure. When I was studying, I think there were 2 or 3 other books that were on most people's desks when they thought about structure. And I will say this, as an educator, I think it's as important for you all to know the engineers working in your time as much as it is the architects working in your time, and the relationship between those two. And so Cecil Bauman was an engineer who also worked as an architect. If you don't know him, it's a great book. It's a quick, easy read. It's like this big, right? And lots of small passages. He was someone who I think had an idea about elegance, but expanded it to let's say, increase the options, both aesthetic, formal, etc., within elegant systems. So in his work, you find a lot of ideas of redundancy and pattern, and you overlay, for example, like these grids on the right, and you'll see the Ito project that worked this out in a second, actually, unless it might be the next slide. Yeah. So he had these ideas of, like, if you just have an excess of structure, that means I can clip 50%. Like if I have 200% structure, then I can start to clip randomly. I can take this out, I can take that out, and I'm left with things like this on the right that sort of like randomly, I mean, random and not so random, but the redundancy is what allows that to happen with a certain amount of ease and flexibility on the designer side. So much, much different than like the Engel approach, where you would have a regular pattern embedded in the structures. He also worked on things like the CCTV tower. That was a structural diagram that became the sort of imprinted facade grid. I think in the end, it didn't actually work like that. So the bigger beam sizes have more space between them, right? So huge beams on the cantilever and a smaller network of beams on the lower side. And I think the other book that was on a lot of desks when I was a student was Guy Nordenson's book with Catherine Sievett. I studied with Guy Nordenson, and he might object to this, but I think he is someone both interested in elegance and a sort of sloppiness to structure, and he works with a lot of course, he would object to sloppiness, but there's a lot of eccentricity, things that operate outside the system, but not in a planned way like you find with the kind of Cecil Bauman work. So he tends to work with a lot of architects that might be sort of like in the kind of fine art, the arts sphere, works very closely with Stephen Hall. This was the Simmons Hall at MIT, which was a Guy Nordenson project. So like both systemized and highly eccentric, but less redundancy, right? So there's not like an overloading of the system. I think that's the rebar pattern. So like where things get weak, you double up in a more local area, but he sort of embraces those changes to the system. We also worked on the new museum, and this is another Stephen Hall building he did. I think most interestingly with Walter Di Maria, worked on the sort of the parking garage, and I think that'll bridge into this idea of genetic and generic. So the studio we were part of last year was really set up around these, so I hope this isn't too remedial and that it's repeating a studio from the past, but I think it could be interesting to see the lineage of that. We had 6 types, and I think what you get in the Angle book is really the generic. And I think what's kind of interesting is where those generics start to get pushed and pulled and tugged into different territories and can become something completely new. And sometimes it's like surprising. I don't think there's much difference actually between an Ishigami structure and a Walmart. One of the sort of like lowest, cheapest order, the other of the sort of most rarefied order, done nearly, that went right to the bottom. How'd that happen? Wait, what happened? I want to go to the top without you seeing everything. Okay. Thank you. How do I go full screen? This one? Is that it? What is it? Control L. I know, I'm not a Mac user. There we go. Okay. So I find this kind of interesting, like the most rarefied and the least rarefied buildings using more or less the exact same structure. But I think you can trace this into all types. This is another Stephen Hall building, a project for a Cinematech in Korea. Surface, slab, edge, line, very sort of cleverly using heavy materials in light ways. So when you turn the slab 90 degrees, you get these sort of thin lines, but it's not much different than a sort of generic, you know, I don't know, Amazon warehouse construction. So like, you know, a lot of, I think, great engineers are able to take these really simple systems and push them into new territory. Surface and volume with arches, voids and infills, vaults, lines, folds, volumes. That's Alejandro Zarapola's Yokohama Port Terminal on the right, and then a sort of generic Renaissance arcade. The Louvre pyramid on the right, a sort of adaptation of a generic space frame building. I probably should have looked for an older space frame because that looks like it's of a newer vintage than the pyramid, but I think you get the point. And then the last one, which I think is an inversion of all the other types, in that in these, the generic is kind of, I don't know if the word improved is fair, but the generic is like explored through the kind of more rarefied architect authored building. But I think what's funny enough is in the long span, it actually happened the opposite way. So like the cathedral or Nervi, those were the sort of rarefied that have been turned back into the generic by sort of cheaper types of construction. So I think it can go both ways, right? So that was the sort of setup. So this was the first project I did with my partner Julian Rose, and we were obsessed with structure. I think we still are obsessed with structure, but we were obsessed with structure in basically how do we undo structure, right? And we wanted to think about reinventing an idea of elegance that was not minimal, but on the complete opposite end of the spectrum. So our sort of rough theory was, yes, you could move towards the absolute minimal, most refined element, or on the other hand, you have a really simple idea of structure, which is enough of anything holds something up, right? That you don't even actually have to think about structure. You take a pile of chairs, you take a pile of whatever, enough of anything holds something up. And so we started these simple experiments. We were also very interested in landscape and some other ideas of structure. I think the other major thesis that we had around the idea of minimal structure was that it did not have to be vertical. Most structure is kind of minimal and vertical. We were obsessed with this idea that you could have a type of structure that expressed itself equally in the vertical and the horizontal dimension. So a pile is a sort of like ideal expression of that, not unlike when the painting came off the wall and Jackson Pollock started painting on the floor. That was a sort of movement of the vertical surface to the horizontal surface. And so we were very interested in, could structure have a similar breakthrough in the way that that painting was able to, let's say, change the orientation of the way structure happened. So we called these drawings. We made little videos to start with. And we were incredibly interested in the generic and the genetic. So this project was in Miami a couple of years after a significant hurricane where aluminum retrofit roofs, structures were placed under roofs because roofs were literally blowing off the tops of buildings. I can show a little preview. So that's a prefab aluminum truss roof that you might put under a gable roof to keep it from blowing away. And we wanted to work with these two generics that were kind of local to that area. One was sand piles, and the other were these sort of off-the-shelf kits that were being deployed everywhere. And we sort of just love that a truss and a pile have the exact same property, right? And they have the same section and the sort of same geometry. So we started playing around with some of these, like the way you have truss diagrams. Could we produce pile diagrams as a real structural device? A mud pile, like well, it's actually a puddle. Mud puddle on the left can't hold up a slab, and then if you get too far to the upper right, you get back to a conventional column. So we wanted to work with an architecture that was sort of stuck somewhere in between. And we worked with Robert Silman Associates. The only reason this project got through was because Robert Silman Associates, they had helped re-engineer the cantilever, the sagging cantilever for falling water. So when the city of Miami kind of like questioned our engineering chops, we had we had very good backup. And I think when you're trying to do new things in structure and engineering, it's like, I don't know, it's like showing up with your lawyer. You bring an engineer, and that really helps. So as kind of loose and messy as the things we were playing with were, they were also super engineered, right? So like table after table after table, each connection at the truss. This this is more like what the project is. So it doesn't really address structure. Except for one fact. So the other thing we wanted to do here is in Miami, every building is like, we were going to work with a certain amount of excess, but in Miami, let's say, unlike New York, where you have bedrock, things are drilled into the bedrock. In Miami, everything sits on shifting sand. So whether you're building a Walmart parking lot or a 50-story tower, you have to put in a sort of counterweight of concrete to hold up your structure. And what we thought of was like, oh, could you build a building without a foundation? So we wanted to create a sort of pavilion that had no foundation. So nothing goes in the ground. And instead of building a footing, we use a pile of sand to weigh the whole thing down. So like embedded in that pile of sand was a really simple set of steel struts, which actually hold the entire cantilever down. It's 40 feet in either direction. And that became the structure. It's a typical detail. And sort of what we ended up with. So, it was a combination of super high precision and kind of, complete informality of the sand pile. Just some shots. And I think what was really exciting for us was the way, if you reinvent structure, you also reinvent use of buildings. And so we had people, families, like building sand castles, acting as if it were a sand dune, et cetera. And it kind of just sort of opened up the types of use for a building also, which we were kind of excited about. There's the night shot. And so after that, that was sort of like, not many people asked us to build other buildings out of sand. And so I think that was like, in terms of career trajectory, I knew to build bigger things, I needed to sort of get at it a different way. And so with James Carpenter, we won the competition to redesign the Gateway Arch Museum, which is a building under the famous St. Louis Arch. When Saarinen designed it, there was a park that was supposed to connect the State House, which you see sort of between the legs of the arch, and the arch grounds. That was never achieved. There's actually, if you don't know it, there's a great movie, maybe 65 or 66, about the building of the arch. I think maybe it won an Academy Award or was nominated for an Academy Award, but it is a really entertaining documentary about structure. And so this was our proposal, was to basically do what Saarinen wanted to do, which was connect the city hall and the arch, and then build a building that would also allow you to connect those spaces, but to do it in a kind of most invisible way possible. So we put 45,000 square feet underground on the historic lawn, and a kind of land bridge over the highway that connects you back to the city hall. And so this is just a sequence of construction sequence of building this, all concrete underground. And then that's the entryway shaping up. That was mostly my responsibility. And so the entryway is all steel and glass. It's it coming together, view from the top. And views back to the courthouse. The section was kind of interesting because you could get light maybe 400 feet back underground, and it was pretty excellent to be way back in that space and get sunlight back there. So maybe a little tiny sub-history of this office's work. James Carpenter is really interesting architect, but also artist who started working in glass a long time ago, worked at Dale Chihuly's studio, and had less interest in kind of art glass, but started to develop different types of technical glass and worked as an artist in resident for Corning and helped develop some of the earliest glass technologies that are now in your phone or found in Gorilla Glass. It sort of sat around in sheet rolls for a long time before they figured out what to do with it. But the office has a history of really working with sort of, at the micron level with details and sort of glass technology and construction. Something quite interesting about this image on the left, I don't know if, yeah, you see my mouse? Yeah. So this, which appears like really thin structure, maybe propping this up or holding this up, it's actually done in the opposite way. So these are attached back at a kind of concrete wall here, and these are actually holding this down, right? So that, like, we work in some pretty surprising ways to achieve a sort of lightness or thinness in design and construction. But yeah, I sort of love that moment where you think this is doing one thing, but it's actually doing the opposite. So this is helping this from actually blowing away and not the other way around. Just some shots from above, and then that's what we're able to achieve with connecting back to the City Hall. Another project that I worked on there was the flagship store for Nordstrom on 57th Street. 57th Street runs all the way across Manhattan. It's a major thoroughfare, and it is dead flat. So every building is maybe, in plan, 1 foot out of plane, for the whole stretch of the island east to west from the other building. And so we had this idea to produce like a different view of 57th Street and through a bay window. And so this, you've seen other architects had done similar things in terms of forming glass, but we were able to use the glass as a sort of a partial column, which allowed you to actually walk out into these spaces. And so instead of approaching a flat wall on 57th Avenue, you can, these are just mock-ups of the process, but now you can sort of step into the avenue and have all of these sorts of different, urban views through this structure. This is also on, for what was maybe for 12 minutes, the tallest tower in New York. I'm sure there's many taller now. Another steel and glass project for the Hudson Yards in New York. I don't know if anyone knows this, property, but Manhattan had run out of large sites. This was one of the last sites that people had their eyes on. It was what developers had their eyes on. It was a large train yard. At one point, there was a proposal to build the Jet Stadium over this and many, many other things. And this is all sort of pre-High Line. This project now anchors the north end of the High Line. But it was purchased by a large real estate group that built an entire concrete deck over the train yard. And it's now become a kind of destination neighborhood. Love it or hate it. You can ask me off camera. But it was certainly a contentious real estate project and became a sort of tower museum for architects. There's a Diller Scofidio tower up and down here. There's Zaha apartments, et cetera, et cetera. This is the yard getting covered. So over here, you're seeing the concrete deck going up on half the yard, and then it eventually covered the full yard. We were contacted because the architect of all of this had probably for 2 years a rendering that showed a glass wall the size of the New York City Public Library without any joints in it. And when they got around to designing it, it didn't quite look like that. And they thought that we might be able to sort of help figure that out. So we were called in to design just this major, this retail wall. I think it's roughly the size of 2 football fields. That wall, which you see here, and I'll go into in some detail in a second, was between some very loud neighbors, Thomas Heatherwick's vessel and the Diller Scofidio culture shed. And so what we wanted to do was not sort of add to that, but to sort of quietly sit in the background. We had some other ideas in mind. I would say that maybe from the beginning, people had doubts about this thing over here. And as a sort of starting point, we said, the last thing we wanted was 2 of them, right? So like glass is highly reflective. Is there a way to make it a one-off? And Thomas Heatherwick really liked that. There's no duplicate of his project. And we really like that too. So we had this idea to produce a curved cable net wall that was angled so you never got a reflection of the vessel in it. So it could be its own sort of autonomous glass structure. This is like quite interesting. No one had ever done a curved glass panel cable net wall before. And basically what a cable net wall is it's all supported by cables behind and struts holding out. So there's the only joints are silicone. So we have like a football size field glass wall that has absolutely no frames, and the only joints are silicone. The other tricky thing is no one, you see it a lot in deli cases, this shape, but this is what's known in the glass world as the hockey stick. And it's really hard to produce, like incredibly hard to produce piece of glass, and most people won't do it. We partnered with an Italian company that works on automotive, one-off automotive pieces of glass, and they might make, the engine shield for the back of a Ferrari, but they hate working with architects. They're always sort of cutting budget. There's not, what this company likes to do is they want to make like an impossible piece of glass that you only make like 10 of, right? And so they don't want to do a tower. It's like, it'll get value engineered, which they won't really get to do what they're good at. And the quantity isn't quite right. So, but they were very intrigued by this. So we were, because it wasn't like a whole tower, a lot of glass, but not a whole tower, and a shape that was like nearly impossible to make in laminated glass. And so we worked with them to figure that out. That's the sort of system in the end. There was one, this is the vertical joint, but there was a horizontal, wasn't really a frame, but it was there to conceal a kind of ugly edge. This is the Hudson Yards under construction, our wall under construction. This is the cable net from the inside. And so it's, you can see the, like, cable net wall has 2 directions of cables usually, horizontal, which are much heavier, and then vertical cables, which are thinner. But you're able to do these enormous columnless spaces with just suspending sheets of glass. And so Schleich Bergerman, who we worked with, had sort of pioneered this technology. And we were often working with them on kind of like how to reinvent things like the cable net wall all the time. This kind of gives you a sense of scale. So like one of these things is about the height of a human. Maybe it's like 4'6", 4'9", not quite 5 feet. And that was our wall. So yeah, we were able to get a completely seamless glass wall out of that. So the details at the edge. I was going to say smaller project, but this is the Hearst Tower in Manhattan. And I'm just going to show this quickly. I did not work on this project, but we did work with cast glass for many. Jamie had worked with it probably for 10 years or so. So this is in the base of the Norman Foster Tower, and this was not structural. It's kind of I guess it's architectural, but it was more of like an interiors project. And what we were trying to do was bounce light down. But we played a lot with structural glass. And a project I ran at the office was for the Henry Ford Museum in Michigan. And Henry Ford was, strange, autocratic guy. And one of the things he did was collect technologies, like if he saw a gas station that had a new type of technology in it, he would buy the gas station and have it shipped to Dearborn, Michigan. He did this at a kind of maniacal rate and with kind of like maniacal precision. So he collected trains, planes, and automobiles, buildings. He was so, I guess, fastidious about it when he bought a Thomas Edison building. Edison didn't want to sell it to him, that he told Edison he would also buy all the dirt under the building and move it to Dearborn, dig it out, put in the building, and put in the dirt from New Jersey under it. So he would do these kind of wild things in his pursuit of collecting and understanding technologies. One of the things he collected was glass. So they approached us about producing a really small building. It was an old machine shop. This is a brick building, old machine shop that was moved from, I actually don't remember if it was Maine or New Hampshire, to the campus. And this would house some of Henry Ford's glass collection. It was art glass, technical glass, colored glass, like anything that was like a sort of new technology in glass, there would be sort of pieces of that here. So this was us sort of attaching some little modern pieces to the old building. The last project I'll show, which is done with my new office, not with this group. I'm working with the company that did the historic preservation of this. They work a lot in Virginia and DC, but also Detroit, and they did the preservation piece, and we did the sort of new piece. And so this is the sort of generic building, and then on the front it had and this is what links back to the Hearst Tower. This is a cast glass vestibule, but it was the first time we were able to use cast glass as a structural element, right? So like, I guess the glass brick is the generic, and this is the genetic, right? Like we've all seen glass brick walls, but they're always fit into a frame, and they're actually not holding anything up. So that, like, even when we were doing the Hearst Tower, like the eye was like, how do we fabricate this? And then eventually, how do we make that into structure? Like, can we actually make it building at some point? And so this is the first time we were able to get this cast glass to work as structure. And so it also helped us make, like, there's some thin steel in here. These are about 150, 200 pounds each. So those would like hardly support this all swaying. And so what keeps it from racking is actually the glass. So the glass allows us to minimize the amount of steel and actually becomes the envelope and the structure simultaneously. And then we had to figure out some really kind of fun and tricky details, like, it's at a museum, like if a kid throws a rock, how do you replace this? And I've seen attempts at systems like this where that was not solved for, and we were really eager, not at this scale, but with glass block walls. And anyway, we wanted to find a way that this could really fully operate as a a responsible piece of architecture, and that you could replace any piece of it. So these were some of the details that went into it. This is the casting process. It's all done in graphite molds. It's pretty cool when it comes out. And it's highly specialized. It's really tough to make these pieces. And when they cool, they sort of bend. So you have to really have to watch after the cooling process when it's manufactured. And some more details, and yeah, so that was the vestibule at Mates.